Good day, hello, and welcome everyone once again for the seventh time with the chapter 7, with the beginning of chapter 7 of the CCNA 20301. This is Sajjad Ghafouri once again for the fifth time, not the fifth, of course, for the seventh time with this chapter on our channel, IIII for networking on YouTube.com. This is chapter 7. This is the final chapter. Finally, we have achieved and reached to the last chapter. Chapter 7 is automation and programmability. The biggest size, or the biggest, let's say, share of this chapter is for automation, which is all about automating the networks, the future of networks. Actually, it's not the future if we need to be specific. No, it's actually some technologies, protocols, concepts, and features that have been released and been used a few years ago in a lot of countries and a lot of networks in the world. But not all the people are educated with that. Not all the people or networks or engineers or managers of networks are convinced with that. So Cisco and other vendors, also Juniper decided to download an automation and programmability features and protocols and technologies to an associate certificate, like what we see in the CCNA and also in the JNCIA of Juniper. So without further talking, we need to start with automation, which is in chapter 7. Chapter 7, actually it will be a big chapter. There will be a lot of talking, of course, because it's producing an entire new thing that you might have never worked before with, you might have never heard of before. And also programmability, maybe you have, for me, just like me as a network engineer, I have no idea about programmability. I haven't done any programmability before, no programming languages, Java, Python at all. No, I did nothing. C++, any of those, nothing at all. Neither in college, where from the section of engineering that I used to study, nor in the CCNA and the Juniper and other certificates that I have taken or studied before. So this is a new thing. That's why I will talk a lot. Also, there will be a bit of backtracer just for some overview regarding some things like scripting. We will use another engine in the end of this chapter, which is EVE-NG, or you can also use GNS3 if you are familiar with, just to show some capabilities in Cisco routers that Packet Tracer cannot show, because Packet Tracer is a limited software. It teaches you things are enough to pass a CCNA exam, but not for a CCNP exam at all. So we will need some extra features to show and discuss in some of the Cisco routers. That's why in the end of the chapter I will use EVE just briefly for a few moments to show something regarding programmability. Also, we will have a free access to the Cisco DNA Center, the new production of Cisco. After they realized that the Cisco DNA Center costs about 89,000 USD, $89,000 for the appliance, then they should also they realize that at least we need to show people what does this device really do, how it looks like from the inside. So they have released some free sandbox that all of us can visit, create a free account, visit that site, and navigate the DNA center. That's we will do it after when we reach the DNA center video. So starting with the automation is simply doing things in your network automatically, or things do happen in your network automatically without you do it manually, without you edit it, without you apply some commands, command after command. Not at all. You need to do something previous, just only one time previously, before an action, before an operation, before software upgrade, before installing a device, etc., or upgrading a device or whatever. You need to apply some prerequisites, and you will leave the network like for weeks, months, or even years to behave automatically. Yes, you can build a network. You need to do a great job. You need an entire team that are familiar, professional, and experts with automation, software-defined networking, and programmability, of course, all three of those, to build an automated network from scratch for only one time, and that's it. You'll leave your network to work and operate for years. It will operate itself, it will monitor itself, it will do some troubleshooting or some troubleshooting suggestion for you sometimes. Yes, it can be happen, depends on your automation solution or your software defined networking, your SDN solution that you are using. Also, it can you visualize and draw topologies automatically for you. This includes all the routers, switches, firewalls, Wi-Fi devices in your network. So yeah, it's awesome. If you have like 30, 40 or even 50 network engineer before, once you build a complete and perfect automated network, maybe you'll need only 5 engineers. These are bad news for engineers because we will have to fire some engineers. Some engineers will lose their job, but the engineers that will keep their job definitely are the engineers who knows automation and programmability. So lucky for you, if you are studying the new CCNA, after you become certified, you are certified as an associate engineer. You might have no expert in working before. You might never had got a job, a networking job before, but you are already certified with a certificate that has the entire chapter of automation and programmability. Also SDN is included with the automation. So you have an idea about all of this, how it's happened, the languages, the APIs, what's happening, some deep dive and discussion inside, some interpreting for the programmability language. That should be awesome for you. Okay, so that's it. We can start right now with automation. First thing of automation that I need to mention is small disk because of some changes. Okay, so the first thing I need to mention of automation is that traditionally, and by traditional I mean the traditional networks that 90% of us know and work with every day until now, even in 2020. By the way, this is day 10 of quarantine in the Republic of Iraq, so you can imagine. I give a lot of effort to complete chapter 7. I gained some weight. I've started preparing for the upcoming series of the CCNA that I will talk about at the end of this chapter. Anyway, so you can imagine, I believe most of you are in quarantine right now. So you have to study hard and prepare yourself with all the series that I will upload for the CCNA. Once the COVID-19 quarantine ends and everything is safe and all the environment is safe and healthy, you must get certified, please. So traditionally, and by traditionally again, I mean the traditional network that we all know right now. Network management is about first installation a new device and applying some initial config. You remember initial config starting from chapter 1, the end of chapter 1, and until chapter 6 we had always done and applied initial config, which is accessing each device alone, connecting the devices, giving IP addresses for each interface, and shutting those shut down interfaces or disabled interfaces, and that's it. That's all the initial config. So it was installation devices, applying some initial config, maybe in the future or after a while modify and update the existing config. Of course, that's something normal. Upgrading softwares. So these are 1, 2, 3 main things that most of us do almost every day, especially if you are a NOC engineer, which is a network operations center engineer, or a network operations engineer, NOE or an NOC. In all of the cases, you will do these like almost every day, or maybe every other day. These are things that you'll always do. So all of those before were achieved either by console for installation and initial config, telnet and SSH for these two, applying scripts or copying config. Like you have an already prepared config, you'll take it as a copy and you would paste it in the device. And this is something that I will do in moments or maybe in the next video by using Packtracer, because applying scripts or copying a config is considered some type of automation. Yes, because it will automate things in one click, in one shot, instead of multiple commands to be applied, and I will inform you how is that done. And also monitoring, we will do monitoring, especially if you are a NOC, Network Operations Engineer, you will definitely do monitoring through SNMP and NetFlow. SNMP, I've talked about this before a lot in chapter 4, and I believe I've shown some images of the PRTG, which is the application that uses SNMP in the network, one of the most common applications that uses SNMP, and also NetFlow that we will talk about in the CCNP exam, or the CCNP course when we will prepare the CCNP course. NetFlow is only about flow and by flow I mean traffic, so it's only about monitoring traffic, while SNMP used to monitor everything: the health of the device, the system uptime, ping, reachability, etc. So all of those are things that you used to do and you are still doing and you might still do for the upcoming years. We don't know how much will this remain, but in all the cases, all of these are done every day by using the method that's called box by box. And by using the term of box by box, I mean you need to access using console, telnet, SSH, applying script, copying config, monitoring SNMP or whatever, all of those separately, each device after another. So you need to access router number 1 to apply some things, then exit, and then access router number 2, apply things, then access switch number 1, exit switch number 2, etc. All of your network devices with all their different types. Each type maybe requires a different username and password. Each type may be monitored through a special category of monitoring, PRTG, SNMP, or whatever application. Each one of them is separated. Depends on the separation of the networks. Maybe you separate your networks into smaller networks. And also each one of them requires multiple sessions of telnet, SSH, etc. So all of those, no matter how much efforts they need, in the end, the most annoying thing is that they must be done box by box. So if you have like 100 router in your network and Cisco recommended a new software upgrade, a new software release, which is a stable release of softwares, it fixes a lot of bugs, it gives you new features that your company really needs, and you have to upgrade 100 router one by one simultaneously. So this is really pain for you. And I believe if some of you are network engineers, that they have definitely lived with that. So with automation right now, stop talking the dark side, please. We know that. We have been in 6 chapters before with that. Start talking about automation. With automation, new devices, number one, the new devices that are added in the network maybe have a network of a router that is connected to a switch. That's from here connected to another router, maybe to another switch, and that's it. So if I bring a new router in the future, new devices will automatically find an initial config and it will automatically access to them and they will config themselves and save that config. This is number one. Number two, some automated quality of service profiles and configurations will be applied to this guy and will be sent to him immediately once it's connected directly or physically to your network. So it will receive the quality of service profiles to know how to deal with the network, how to deal inside the network, how to deal with the endpoints that are connected to it. Also some automated AAA profiles to itself and to the devices connected to it. Okay, so these are 3 awesome things that will happen just once you connect your device. That's it. You need to do nothing. This is awesome until now. This is a lot of config that you have shortcutted. Number 4, it utilizes scripts and tools just like the traditional networks, because in traditional networks there is, especially in the Cisco routers or Cisco devices, there is a scripting feature that's called the TCL in the Cisco devices, which is by using some scripting and automation language, scripting language, you can generate some automatic config, save it inside the device, and the device will apply it like maybe once every 24 hours, or depends on the time that you modify. Maybe every day at 3 a.m. please collect all the logs, do some show commands, save all these results as a text file and send it to this server. So in the morning I will just take a copy and I will view it myself. So this is something automated that you can do in the device by in the traditional network or in the automated network, both of them by using what's called scripting. And one of the many examples of scripting is Cisco TCL, which is a scripting feature built in inside the device, Cisco devices. Number 4. And number 5 is standardizing or standardize some procedures. You remember a few moments ago I mentioned that just in case a new software release were there and you have 100 device, first thing you need to do is that you need to check if this new software image is applicable and match all the hardware versions or the software versions of the other devices. What do you mean by match? what I mean is something that I have faced before in the network, which is maybe let's say that currently this router have maybe Cisco iOS version number 13. This one has version number 15, 15, and 14. So Cisco recently have released the new version of 16, and actually I'm using these in my ISRs, the ISRs that I manage. So version number 16, a new version that's released for the Cisco routers, maybe and images also at the same time. Let's consider just virtually, consider all of those as routers. What I need to do right now is to upgrade all of those different versions for those devices with the new 16 iOS image, the new 16 version 16. The first thing I need to consider, which is something important and might happen with a lot of devices, is that some old legacy versions cannot be upgraded directly to the latest release. What I mean is that the main releases are maybe like 13, 14, 15, 16. So this one was released in the beginning of 2018, in the mid of 2018, maybe on the mid of 2019, and in the beginning of 2020. Maybe these are the release dates for them. What happens is that maybe some devices must or cannot skip two versions in a single upgrade. Like if you have version number 13 installed in a device, then the maximum software upgrade or the maximum version iOS image that you can upgrade this device to is by jumping two main versions only. So the maximum version that I can apply right now for this guy is version number 15. After that, I need to upgrade it again to version 16 after it becomes in version 15. You see, so this is a procedure. When you have a new software release and that has been released by the vendor, you need to check all of your network devices. Just imagine again, if you are working with a big network of 100 router, then definitely this will be pain and take a lot of efforts, hours, and surely maybe for me, maybe for you also, some headache also with that. So you can imagine that I need to check all of those 100 device, all of their software images. So which one of them can be upgraded directly to the new software, which of them needs maybe 2 or 3 steps of upgrading, 2 upgrades, 3 upgrades, until we can reach the latest image of 16. You can see that. So this is a procedure. So standardizing some procedures or standardize some procedures is mean you can previously just assign some procedures in the automated network that like some if and then or true and false. If the software is like 2 images ahead of the latest image, then upgrade it directly. If this device is maybe late like in 3 images or 4 or greater, then please upgrade in this upcoming procedure, like upgrade from 13 to 15, and in the upcoming 24 hours upgrade from 15 to 17, and that's it. This is a procedure. So this is how to standardize from some procedures regarding software image per device model, which I've been talking about, and the upgrading procedures. So that is what I was talking about or mentioning in the few moments ago or a few minutes ago. So this is automating the procedure. All of this has been automated. What I mean right now is that when Cisco in the future announces a new software image, you will download it and you will store it in your server, and then you will apply to the automation application that you use, and I will talk about them in the upcoming videos, that there is a new software. Please go ahead. The procedure of upgrading is already identified inside the devices when you have established your network. So that's it. Leave it. Leave your network. Automation will, in a few hours, days, or weeks, it depends on your settings, on your profiles that you have applied or configured in your automated network, will automatically schedule some operations. Okay, and we'll start upgrading the device, each one per its model, per its software image. Depends on the time also. Maybe you can specify every day from 1 a.m. to 6 a.m. start upgrading a device. Only upgrade one device every 15 minutes, and that's it. Leave the automation to automate. This is the awesomeness so far for automation. So number 6 is scheduling an operation at 3 a.m. upgrade, restart, and send the logs after you restart to server number A, and that's it. Leave the device. When you come to the next morning, you will access server number A. You will see how many devices were upgraded correctly. They are working, no problem. That's all. So all of that was automation. And also sometimes you might also have the good benefit of automated troubleshooting. Maybe you have like something in spanning tree, in OSPF, etc. Automation will initially do some troubleshooting and will send you some uh, already prepared logs, like you can see, and organize and verify, so you can initially or in a fast, maybe in short period of time, can identify and troubleshoot the problem. This can be happens. All of these 7 things above are done through CLI, because this automation application and server are accessing your devices using a CLI, of course, through SSH. Also, they will use SNMP. They will use new protocols that are called netconf and restconf that have a specific amount of weight to be mentioned and studied, I believe, in detail in the new CCNP exam, in the Enterprise Core exam. We will definitely talk about them when I produce the CCNP exam. Step number 8, brilliant step, really genius, which is topology visualization and monitoring. Topology visualization is that before, in the traditional networks, if you want to draw a topology of your network, and you will definitely need to know how your network looks like, then you need to do this manually by accessing all of the devices, knowing all of the neighbors of the devices, knowing how your network is connected with all the main and redundant backup connections. I need to draw them all by yourself by using Microsoft Visio, by using some eDrawMax, which is another application for drawing, etc. Whatever application that you need. Also, the Zabbix monitoring system also can allow you to monitor and visualize some topologies, draw your topologies inside the same Zabbix server. So all of those will happen manually, just in case you are a new engineer and you had a task to draw the latest topology of your network. Your network, with all its types of devices, might have at least 300 to 500 devices. So yeah, good luck with that by drawing all of those with all the physical connections and everything. You can imagine that. So in automation, when you connect a device, it will automatically insert itself, draw itself in a GUI interface where you can see all of your devices, how are they connected, which interfaces are up, which links are up, which links are down, which interfaces are disabled, with all the various types of devices. Yes, this is brilliant, but this is costly, but this is automation and the future of networks. All of those above things are done for visualization and monitoring by using an SNMP manager protocol and the NetFlow collector. They are kind like similar to the previous traditional networks, but the difference is that it's an SNMP manager and a NetFlow collector. All of the above led to the automation, of course, reduce or even eliminate. Actually, we need to eliminate, not to reduce, but we need to eliminate the box by box criteria, because I will not access many devices in the future with automation or automated networks. Only I will drag and drop the new software image and the devices will upgrade themselves automatically. Smaller staff is needed. I have talked about that. Time saving, definitely time saving, and configuration consistency. What I mean is that when you plan, design, and approve a special or a standard method or a procedure of software upgrading, or of initial config, or whatever type of config, like adding route for the loopback interface, adding some OSPF, advertising something for the core, etc. All of these you can do them only for one time, test them in the lab, test them in one of your networks, in a small part of the networks. If they works, then that's it. You can do them generally, apply them generally for the entire network and for the upcoming devices and nodes, and by nodes I mean devices in your network in the future. So that's it. It's the same config, the same commands will be applied to all of the devices. So it will not be like yourself accessing to device number 1, applying some commands, saving, exit, device number 2, applying some commands, save, exit. When you reach device number 15, might start to get tired, your eyes maybe start to glow a bit, blur a bit, they cannot really focus like the same device number one. So maybe you type some command or commands mistakenly, and later one of those devices will not give the same results of the previous devices. Why? Oh god, I need to troubleshoot for minutes or maybe hours until I find out. Config consistency is that the same config that did pass the tests and lab in the first time, that's it, it will be applied to all the devices in the future. So if problem happened with the device, it's not because of the config that we have applied recently, because that config is already tested and working with another 100 device. So that's it, just for an introduction for automation. I hope it was clear to you. Maybe it doesn't really have a lot of information, it's only the differences and the challenges between the traditional networks and what automation will produce to us in the automated networks. I hope everything is clear. Just in case it wasn't, the comments are available always down below in the video, and just in case it was clear, we can jump to the upcoming video of this chapter. Thanks a lot for watching and hope to see you in the upcoming video. Goodbye.